Welcome back to Unlocking Ancient Family History. In our previous episode, we explored the rise of Homo ergaster and Homo heidelbergensis, delving into the adaptations and contributions in human evolution. Today, we turn our focus to one of our closest relatives in the evolutionary tree, the Neanderthals. Imagine a time when the Earth was not home to just one, but multiple human species, each carving out their existence in the vast landscapes of our planet. Among these ancient relatives were the Neanderthals, whose legacy left behind an indelible mark on the human genome. Neanderthals, often depicted as the rugged cavemen of Europe, were far more complex than commonly portrayed. Their story is intricately woven into the fabric of our own, and through the marvels of modern science, we can trace the echoes of their existence in our DNA. Let's embark on a journey to uncover the profound impact of Neanderthal DNA on who we are today. Neanderthals evolved from a common ancestor shared with Homo sapiens around 400,000 to 500,000 years ago. They are thought to have descended from Homo heidelbergensis, or a similar species that migrated out of Africa into Europe and parts of Western Asia. Over time, Neanderthals adapted to the colder climates of Europe, developing robust physiques and advanced tools. Their lineage became distinct from early modern humans, leading to the emergence of a species uniquely adapted to the Ice Age environments of Europe and Asia. Research indicates that Neanderthal populations in Europe were divided into three main subpopulations: Southern, Northern, and Eastern Europe. Each had distinct migration patterns and survival rates. Southern Europe, subpopulation A. This group resided in areas like Spain and Italy. Considered a refuge zone during harsh climatic periods, they were the last Neanderthal group to disappear. Northern Europe, subpopulation B. Inhabiting regions like France and Germany, this group had a higher migration rate southward, contributing to the southern populations. Eastern Europe, subpopulation C. Found in areas like Russia and Ukraine, they had very low population density and high rates of endogamy, often migrating westward and southward for better opportunities. So, to clarify, the division into these subpopulations wasn't just about geography, it was several factors. Imagine Europe as a vast, rugged landscape with natural barriers like mountains and rivers. These features created isolated pockets where Neanderthals settled, leading to distinct regional groups. But it wasn't only the landscape. Time played a role too. Over 1,000 years, different groups faced unique challenges, from ice ages to warmer interglacial periods. These varying conditions drove evolutionary changes, making each group slightly different. Genetically, as these groups adapted to their specific environments, variations emerged. Subpopulation C from Eastern Europe is particularly fascinating. This group ventured beyond Europe, migrating into Asia and spreading Neanderthal presence across a vast area. Their journey into Asia underscores the incredible adaptability and the expansive range of Neanderthal habitation. This eastward expansion hints at a complex web of migration and adaptation, painting a picture of Neanderthals as resilient and resourceful beings, constantly on the move and evolving. This demographic weakness, coupled with environmental and social constraints, might have contributed to their eventual demise. Understanding these dynamics helps us appreciate the delicate balance that once existed among these ancient humans. The study, The Fate of Neanderthals by Hublin et al., 2020, provides a comprehensive analysis of these population structures and their vulnerabilities. The introduction of Neanderthal DNA into the modern human gene pool happened through multiple interbreeding events. By analyzing patterns of genetic variation, scientists have pinpointed these events to tens of thousands of years ago. Such genetic mingling has left a profound legacy, with modern humans carrying Neanderthal DNA. The work by Shaman et al., 2012, titled The Date of Interbreeding Between Neanderthals and Modern Humans, sheds light on these crucial moments in our shared history. Something I found particularly interesting was that the interactions between Neanderthals and early humans were complex and multifaceted. There is substantial genetic evidence indicating periods of peaceful coexistence and cooperation, evidenced by the presence of Neanderthal DNA in modern human genomes. This interbreeding suggests that there were times when these two species lived in close proximity and formed bonds that went beyond mere survival. For instance, the shared use of tools and cultural exchanges likely facilitated these peaceful interactions. However, these interactions were not always harmonious. Archaeological evidence, such as trauma marks on fossilized bones, indicates that conflict and competition for resources were also part of their interactions. These conflicts could have led to violent encounters, particularly in regions where resources were scarce. The discovery of weapons and defensive structures in Neanderthal and early human settlements further supports the idea of occasional violent clashes. This dynamic relationship between Neanderthals and modern humans is a testament to the complexity of our shared history. Extracting and analyzing ancient DNA, aDNA, from Neanderthals' remains has been a significant scientific achievement. Despite the challenges of DNA degradation over time, researchers have developed methods to reverse chemical changes and accurately compare Neanderthal and modern human genomes. The ability to decode the Neanderthal genome has provided valuable insights into the genetic contributions to modern humans. For more on this, see the article Ancient DNA and the Neanderthal Genome by Green et al. 2010. Contrary to earlier beliefs, recent studies have discovered remnants of Neanderthal genomes in African populations. This finding challenges the previous assumption that Neanderthal genetic material was confined to Eurasian populations. Studies like Neanderthal Ancestry and Adaptation to Local Environments by Verneau and Eki, 2014, highlight the complex history of human migration and interbreeding across different regions. Neanderthals were adept at surviving in the cold, glacial environments of Europe. Their robust physiques and specialized tools for hunting large game, like mammoths and woolly rhinoceroses, were adaptations to these harsh climates. They also made use of natural shelters such as caves and may have constructed simple shelters to provide additional protection from the elements. The use of fire was also crucial for warmth, cooking, and protection from predators. Burials with grave goods and the arrangement of bones and artifacts suggest that Neanderthals had some form of spiritual beliefs and rituals. This is supported by findings such as those discussed in Neanderthal Burials by Rindu et al. 2014. Neanderthal social structures were complex, involving close-knit groups that cooperated in hunting and shared resources. Evidence suggests that they cared for the sick and elderly, indicating a level of social support and cohesion. Interestingly, Neanderthal DNA influences a variety of traits in modern humans, including skin and hair characteristics, immune responses, and even disease susceptibilities. For example, the study Neanderthals' Genetic Legacy by Harvard Medical School found that Neanderthal DNA is associated with traits affecting skin biology, such as the risk of developing sun-induced skin lesions and keratosis. Additionally, this genetic legacy is linked to metabolic and immune system traits, highlighting both beneficial and maladaptive effects. Neanderthal DNA has also been linked to psychiatric and neurological effects. Research published by Vanderbilt University found associations between Neanderthal DNA and a range of traits, including the risk for depression, nicotine addiction, and blood coagulation. These traits provide adaptive advantages in an ancient environments, but may pose health risks in modern settings. As we wrap up this journey through time, it's pretty amazing to see how Neanderthals connect with the broader story of human evolution. Neanderthals were more than just brutish cavemen. They had rich social structures, cared for the sick, buried their dead with rituals, and even created art. These behaviors hint at a spiritual side that connects best to them in profound ways. Their genetic legacy is woven into our DNA. From immune responses to skin and hair characteristics, Neanderthal genes influence various traits in modern humans. The interbreeding events that left Neanderthal DNA in us highlight times of peaceful coexistence and integration, despite the conflicts and competition for resources. Understanding human evolution deepens with each discovery, reminding us of our resilience, adaptation, and connection. Tracing the genetic variations among Neanderthal groups helps us understand their migration and interaction with other hominids. These genetic traces link Neanderthals to their ancestors and to us, revealing a complex web of relationships and adaptations over hundreds of thousands of years. Stay tuned for our next episode where we dive into the journey of DNA itself. We'll trace the oldest known hominid DNA to modern humans, exploring how these genetic connections bridge the eons. Don't forget to like, subscribe, and hit the notification bell to join us on this fascinating journey through time.